you very much for this nice introduction. Salam alaikum to anybody. I hope you can hear me well, even from distance, from Czech Republic. I would like to say that I'm very appreciated to be invited in this conference. My topic today is maybe more methodological and technical than that of the previous lectures. We will deal with the measurement and recording of historic buildings and interpretation principles of historical architecture. Sorry. Start with this topic, we have to define obvious or usual differences between standard architectural and heritage documentation. Then we will define or describe the types of the heritage documentation usually used in our work. Then we proceed to methods and means of documentation. Then we will deal with the stratigraphical method as an important tool of analysis and interpretation of the buildings. And we also make a notice on different forms or different levels of building survey. So, architects, historian of architecture and building archaeologists are used to make and read the documentation of buildings. The usual, but sometimes the architects and archaeologists don't understand well each other in terms of standard architectural documentation was made or made simply for different purposes. Architects are used to make documentation to build houses, to construct the buildings, or to reconstruct the monuments. So this type of documentation has no scientific ambitions. It means that for the purpose of building, the documentation might be schematic, might have a tendency toward orthogonality, because modern building, modern construction work tends to orthogonality, use the orthogonal materials, and all space and rooms interiors should be orthogonal. So this tendency we can see also in the documentation of historical buildings made by standard architectural ways. Therefore, there is also absence of details and contrary presence of for example, arts which are under the surface, which are not visible. Architects might have to depict the missing parts or unchecked portions of the structure.
Okay.
It's also very common that standard architectural documentation miss an important details like vaulting system, openings, and any non-standard elements which are, on the contrary, very important for architectural historians. You can compare two documentations, two floor plans of one building, one Czech monastery. One was made by not very educated architect, and the second one was made by architectural historian. So you can see the difference. It's a striking difference, which in the case of the first plan doesn't make this type of documentation usable for us. In general, the types of heritage documentations are very similar to standard architectural documentation. We are using ground plans. As you can see here, a ground plan of Jami al-Mujahidi in Al-Mosul. We are using vertical sections, either longitudinal or transversal. We are using elevations and also oblique views, which might be simply a photograph or a perspective drawing, and also 3D models, which is a kind of integrated documentation. Contrary to common opinion, the basic means which we are using for documentation are very effective and universal in use. So if you are looking for a description of recording methods in standard textbooks, you probably encounter the more sophisticated methods as a standard. But I would like to point out that this is not standard. This is kind of advanced methods which are used by institutions or professionals. But if you, as an individual researcher, are trying to make recordings of standing structures, you can very successfully use this basic set of aids or means. So you probably all know this kind of devices, maybe except this one. This is mold, which is a standard device for recording of molded elements, for example, cornices or molded architectural stones or something like this. You need also camera, but it shouldn't be a professional camera. It should be. It could be also a smartphone with a good resolution of the pictures. From this advanced aids or devices, you can use Pentagon, which is a very traditional tool, which enables you to see simultaneously a control point which is in front of you and points perpendicular to it in right and left. So you can use this easy thing to make perpendiculars. Laser distance meter is nearly standard today because it's very universal. It's not so expensive to buy, so you can use it either in a form of portable machine, or to to put it on tripod and measure points on the facade. It's also possible with advanced devices like this. This is total station, a standard professional machine, which is however very expensive, probably impossible to buy by individuals, and laser scanners, drones, and other devices for photogrammetry and photo-optical documentation, which is also probably impossible to reach by individuals. How to record? Which kind of methods we can use? The easiest way to make a floor plan is to take running dimensions in straight lines and with diagonal checks. These diagonals are not so important only for checking, for control, if the room is orthogonal or not, rectangular or not, but you have to record them because this method is a kind of trigonometric method. So you use the triangles in the sketch for construction of drawing. This is a structure of triangles in this small sketch, which you have to record to be able to construct the drawing afterwards. So this is a very easy method. You can use only this basic set of aids of devices, but it's very demanding on accuracy. You have to be very accurate. The second possibility, which can everyone use, is a floor plan measurement using measure lines and perpendicular measurements. So you have to construct the main measure line either inside the building in the interior or in the around the perimeter, and then you have to use, for example, the 1 meter bar and the pentagon to measure exact the perpendiculars on the important points of the building and measure the distances, both this distance from the beginning and this distance. It's also very easy method, but you have to be also very accurate in construction of right angles, of course. This orthogonal method should be also used for recording of sections. You have to project 0 level in the space in the room, and from the 0 level you have to measure up or down in stable distances or on important points, and again record the dimensions from the beginning and from the 0 line up or down. It's also very easy method. You use this kind of devices. This is pentagon. This is level. Much more advanced the polar methods. Is a polar method which is there is a condition. You have to use measure measure machine like total station or earlier older methods. The basic principle is that you use one or several control points from which you measure horizontal angle, this angle, and the distance. So that's the name polar. You make polar measuring from one point in a perimeter. And finally, there is a big group, large group of photo-optical methods, which is very popular now in the history of architecture, of course. But problem is that to reach this very effective results, you have to use very expensive machines, very expensive devices. There is one exception in photo-optical method, and this is use of rectified photographs, which is also very easy to learn and very easy to use. It's called also one-shot photogrammetry. The basic principle is that you take a good, clear photograph of the facade, which should be plain, should be without any conspicuous recesses or protrusions. So the facade should be plain, and you have to make control points on the facade before taking the picture. There are several methods how to fix the points facades. We can skip this problem, but it's not very difficult. You can use easy basic measurement methods, or use, for example, total station. And then you take the picture. You have to measure precisely the dimensions or coordinates of the control points on the facade, and then in special software, which is easy to get. Certainly, there are expensive softwares, but there are also very easy freewares. You will rectify the picture to make it absolutely perpendicular. And from these perpendicular pictures, you can make photo plans, which you can see, for example, here, the line of facades of buildings in Portugal, I think. And again, in a special software, it's possible to adjust the pictures, the raster pictures, to vector images, or you can redraw it by your own hand, of course. So this method, use of rectified photographs, one-shot photogrammetry, is also very user-friendly and accessible for anyone. Now we can talk about what's the purpose of this very accurate, very detailed documentation. We have to use this documentation for application of stratigraphical method, which is a basic tool for analysis and interpretation of the buildings. You probably know archaeological stratigraphy, which is a basic principle of archaeology at all. It means it's identification of stratigraphical units, so-called contexts, and interpretation of their sequence. For you as non-archaeologists, maybe probably interesting this book, which was published in 1979 by English archaeologist Edward Harris. It's a basic textbook or methodological monograph about principles of archaeological stratigraphy, which is from this year also available in Arabic. So you can download it for free, and it's possible to compare the modern methods of archaeological stratigraphy with needs and requirements building archaeologists also. So archaeological stratigraphy is a tool for reconstruction of the development and chronology of the archaeological situations or a single artifact like site or building. We should make note about stratigraphic signs, stratigraphic clues on the structure. So what's important to follow, what's important to see on the buildings, what can reveal for us some stratigraphic or chronologic information. In single a floor plan like this, it's a Georgis in Mosul. It's a good plan made by in 1980s by Iraqi heritage surveyors. So the plan is pretty accurate, and you can see here the central nucleus of the building. This is the mosque, the main mosque. This is another musalla. This is also another musalla, and this part is the grave, is a mausoleum of Nabi Georgis. And you can see here the difference, striking difference in the thickness of the walls. It's one important stratigraphic clue. If the wall changes the thickness, it means something. It means some probably different period. There is another clue in the same picture. This part, especially this part, the tomb of the Prophet, is about 1.20 meters deeper, is recessed than the rest. So differences in floor levels, differences in orientation are important stratigraphic indications which we need to look for. So this is interpretation. The blue color highlight probably medieval nucleus, medieval core of the building. Another clue, another indications are joints. There are not only vertical joints, but also the complicated joints in ashlar masonry, which can reveal different periods. For example, here in Madrasa Qubahan, this part is a later addition of the building. You can see it on the section. This part is later than the background. So therefore, you can reconstruct the stratigraphic and chronologic development of the complex. This part is the early structure, and this green parts is a later madrasa. So joints, irregularities of any kind, punctual discrepancies, it means blocked openings or openings which doesn't lead to any space. This kind of discrepancies are important to record. And also the last thing is plaster layers. Sometimes you can see different layers of plaster on the wall, and every plaster layer corresponds to any period, to some period. For example, here you can see mihrab in shrine of Imam Yahya in Mosul. We have only this photograph, unfortunately, but anyway, you can see here a complicated situation where the old surface with plaster was covered by another plaster, which is run towards the edge of the mihrab. So it means probably we have no certainty. We are not sure and cannot be sure because the building was destroyed. This area of old plaster corresponds to the first phase of the building, and this layer which covered the first one is contemporaneous with the mihrab. So the mihrab was probably later, was set in additionally to the building. All these stratigraphical details should be again marked back in the documentation in this way, either with use of color or graphic codes. You can use for this analysis. You can use ground plans. You can use elevations and also sections. It's very important because if you have this combined picture, you can analyze in very detail the building history, and you can consider each phase as a alone-standing, self-standing construction phase, with considering the missing parts of the structures also. Finally, you can construct this composite, very large urban complexes in building analysis, when every color corresponds to some period of construction from the oldest to the latest. We should mention that building archaeological survey has different recovery levels. It means different levels of detail or complexity. In some cases, when the building is undergoing a big restoration, when all plasters are removed, you have to apply complex invasive survey, which should be very systematic and very complex. Standard survey, on the contrary, is targeting buildings in use covered by plaster, and you can make also a quick improvised survey in case you you would like to rescue some important information, and you have no device in the hand available to make some complex systematic documentation. So you take a camera or smartphone, you make the picture, and if you have a measure tape or something like this, you can measure easily dimensions and mark them into the image. So such a measured sketch of the find, which is based on a normal common photograph, is also very important piece of documentation, and you can use aids devices which are on hand. To make a conclusion, I would offer two thoughts instead. Buildings are by all means the most complex artifacts of the past, the most complex things created by man in the past, with a very complex history of changes, refurbishments, and with leveling of meaning. So be please very suspicious if someone is trying to reduce this multi-layered history of the building on one easy ground plan, one easy piece of documentation. There is no easy way to handle with heritage structures, both in documentation and in restoration or conservation. So buildings are too complex to catch them very easily. However, on the other side, on the other hand, complexity of heritage architecture doesn't necessarily imply complex documentation methods. Every good piece of documentation, for example, a rightly measured sketch, set of photographs, makes a difference, and important is to say that any experienced person could be engaged in this process. This is an example of bad practice from Mosul. Shrine of Imam Zaid ibn Ali in southwestern part of old Mosul was probably an important medieval structure, but no one took care, no one interested in this building. So only these four pictures, which are very fragmentary and without context, are preserved of this shrine, which was destroyed by Daesh in spring 2015. So this is a bad example of what left if no one takes care. The reading to documentation methods in historical buildings are not so very abundant. So I can recommend these four monographs. Two of them you can download from the website of English Heritage. Thank you very much for your attention.